Whenever I think about climate change, I don't usually start with the temperature trend. Like you're suggesting, I'd start with carbon dioxide. We know that carbon dioxide is a greenhouse gas that was measured in the mid-1800s, and any spectroscopy lab in the world can see the wavelengths of radiation that carbon dioxide likes to absorb and emit. And we know that it absorbs energy from the Earth's surface and then also emits energy back down to the Earth's surface.
Well, by energy, you mean heat?
Okay.
To make it simple, we're talking about basically infrared energy, aren't we?
Yeah,
Heat.
infrared. Yeah, that's fine.
So what you're saying is the more CO2 that there is, because it can absorb more of that energy, that there's more opportunity for that energy to be soaked up.
If you put more CO2 in the atmosphere, you will get more energy down here at the surface, right? That's really clear. We've been adding about 30 billion tons of carbon dioxide per year, and that accumulates in the ocean, atmosphere, and land, and that's from fossil fuel burning. The short story is that energy has to go somewhere. If you double carbon dioxide, that's energetically equivalent to putting a 4-watt light bulb on every square meter of Earth's surface and letting it run 365 days a year, 24/7. 4 watts might not sound like a lot, but the Earth is gigantic, so if you put one of these light bulbs on every square meter, that ends up being energetically equivalent to about 40 nuclear explosions per second, which is...
Okay, so the physics argument is that because there's more of something that can soak up the energy around, there should therefore be more opportunity to interrupt that energy before it goes off into space, and the Earth system should become warmer. So that's what the physics says. Right. But what people are saying is that when you look at graphs and things like that, there appears to be some disparity between what the carbon dioxide is doing, what the temperature is doing, what the current climate measurements and predictions are doing. How do climate scientists like you respond to those sorts of allegations?
Right. What the gentleman who asked the question was referring to was the surface temperature, right? The just land surface temperature. Well, not just land, but the surface temperature. And that quantity can be affected by how energy is exchanged between the atmosphere and the ocean and the cryosphere. So if that's the only number you're looking at, you will see some wiggles. It will rise, it will fall, and some of that is just due to exchanges of energy between the different parts of the climate system. An easier to read thermometer, I might suggest, would be something like ocean heat content. It takes more energy to raise the temperature of the ocean by 1 degree than it does the atmosphere, because you can just put a lot more heat into the ocean. It has a higher heat capacity. So if you look at the ocean heat content over the past several decades, that has been increasing. It looks steadier than the surface temperature, which does have some of these increases and decreases.
So is it